Okay, everybody, this is a continuation of review set number 3, our third video in the series. I posted the first couple, of course, about a week or so ago. But anyways, let's get going here. So on this one here, as you can see, that this is something different. This is something actually we talked about a little while back in first semester. But let's do a little review. Do you guys, for example, remember Pascal's triangle? Well, Pascal's triangle is a special triangle based upon patterns of binomial powers, basically. But basically it goes like this. It starts with 1, then it goes 1, 1, then it goes 1, 2, 1. The 2 came from adding the 1 and 1 above it together. The next row goes 1, 3, 3, 1. The 1 and 2 makes the 3. The 2 and 1 makes the 3. And we're going to go one more here. 1, 4, 6, 4, 1. The 4 came from 1 and 3. The 6 came from 3 and 3. The 4 came from 3 and 1. Now we could keep following this pattern over and over again. But all we need is to go to the 4th power to do the problems that are assigned on this review sheet. So, the key thing to notice in problem 53, they have a 4 power here. So that's why I knew to stop basically right here. That 4 power gives it away, that 4 right there. So this is basically what I refer to as my 4th power row. 1, 4, 6, 4, 1. So basically all you have to do is go 1, 4, 6, 4, 1. Notice the first term is x. So I know it's going to go x4, x3, x2, x1, x0. I know the y is going to do the same thing backwards. It's going to go y4, y3, y2, y1, y0. Note that anything to the 0 power is simply 1. So x to the 0 is also 1. And we would put this together, which I will do in another video. But all they wanted, if you read the question carefully, is they just want the first term. This right here is my first term. This would be my second, my third, my fourth, and my 5th term. Okay? But all they wanted was the first one. So what is the first term in this problem? It's just simply 1 times x to the 4 times another 1. Simplifies to x to the 4. And that's the answer to the question. Pause the video if you need to. Okay, here we go. Now we're going to use the same Pascal's triangle. Note this one, the power is a 3 though. So we're actually now going to look at this row, which I refer to as the 3rd row, or the 3 power row. So I'm going to be using 1, 3, 3, and 1. All right, so here I go. 1, 3, 3, and 1. And note that the b will have a 3 power on it. So b to the 3, b to the 2. Basically, I'm just counting down, right? B to the 1, B to the 0. Perhaps the only tricky thing about this one is that right there is actually a -5. You have to keep track of your negatives. So I'm going to do -5 to the 0, -5 to the 1, -5 to the 2, -5 to the 3. Guys, use the parentheses so you avoid messing up with the negatives, by the way. But again, this is the pattern. The first term, you basically count down. The second term, you count up to the highest power, which in this case is 3 again. So let's get to the answer. They want the second term. Well, this is my first term. This is my second term. So the answer is 3 times b squared times negative 5 to the 1. Of course, negative 5 to the 1 is simply negative 5. 3 times with negative 5 is negative 15 b squared. We are done. That is the second term in that expansion there. Guys, pause the video again. Now, what I'd like you to do now is try number 55 on your own and see how you did. So pause the video basically and give number 55 a shot. Okay, hopefully you did number 55. Let's see how you did. Follow the blue here. Did you start out with 1, 3, 3, 1? Why? Because the power was a 3 power, right? And according to Pascal's triangle, we look where we know we have the 3 power in there. Did you then take the 4a here, and because of the 3 power, you just did 4a to the 3, 4a squared, 4a1, 4a0, of course, is just simply 1. And finally, did you take negative 2b here to that 3 power, and you counted backwards? Negative 2b to the 3, negative 2b squared, negative 2b1, negative 2b to 0, which of course is 1 again. Finally, what was the question? They wanted the second term. This would be my first. This is the second they want. This would have been my third term. This would have been my fourth term. But they wanted the second term. So I would just take in 3 times 4a squared times a negative 2b to the 1. Simplifying, I know I have 3 times 16a squared. All I did was 4 squared and a squared right here. I know negative 2b to the 1, of course, is just simply a negative 2b. I'm going to times my 3, 16, and negative 2 together and get negative 96. And I have a a squared, and I have a b, and that is my second term for problem 55. Pause the video one last time, guys. So guys, I actually have 2 more videos using Pascal's triangle to do these expansions. So heads up for that. See you in class.